Welcome back everybody to 1.7. So 1.7 is called simplifying expressions. Okay, so simplifying expressions. So all that an expression is a quantity that contains numbers. It could contain variables, math operations. Okay, so like adding, subtracting, multiplying, division. And remember, variables are letters that represent mathematical quantities. Okay, so they're letters that represent numbers. Okay, and another thing we're going to be dealing with, and I'm going to use the word terms a lot. So this may be a number or a number in one or more variables. So let's say you were given something like 2x minus 3. Okay, I'm going to be saying this is the first term in the problem, and this would be the second term in the problem, so I'm going to be using that as well. So it's just something to be aware of. Okay. And what our goal is in simplifying expressions is to solve these problems and simplify them with using similar or like terms. Okay, so it means the same thing. You might see them say similar terms, you may see them say like terms. I typically say like terms. And all this is two terms with the same variable as well as raised to the same power. So not only is the variable the same, the exponent has to be the same as well. So if something was a and a squared, yeah, it's the same variable, but it's not the same exponent. One is a raised to the first power, one is a to the second power, right? A squared, a to the second power. So it's different, okay? So like terms could be something like 3x and 4x. They both contain an x, and they both have the same power. They're both to the first power, right? Which we typically don't write, but they're exactly the same, okay? 2xy squared and 6xy squared. So we're going to see if those are like terms. Well, they both have an x to the first power. That's great. And they both have a y squared. So not only does the variable have to be the same, but the power has to be the same. So if I had 2xy squared and 6xy, we need to see if these are like terms. So yeah, they both have that x to the first power, but our y squared and y to the first are different, so those are not like terms, okay? So you could not combine those together, okay? All right. So they may ask you to simplify, okay? And let's say they gave you 5x plus 2x, okay? And you're asked to simplify. Well, the first thing we're going to see is if they have like terms. Well, they both have x's. They're both to the first power, so those are like terms, okay? So when you're adding these like terms, all you're going to do is add together the numbers that are out in front. So I have 5 plus 2 gives us 7. You keep the variable of x. You don't add the x's together, right? You're just keeping that variable of x. So if I had 12a minus 7a, first thing we're going to do, are they like terms? That's an a, so yes, they're like terms. So we're going to go ahead and do 12 minus 7 gives us 5. We keep the variable of a. You don't do anything with it. Keep that variable of a. Okay? Let's say we were given 7y plus 6y minus 3y. So the first thing we're going to see, are there any like terms? Yes, they're all the same. They're all y to the first power. But what we have to keep in mind is our order of operations that we've been dealing with. So we need to handle the 7y plus 6y first, right? Remember your order of operations, addition or subtraction, as it occurs from left to right. So addition first, we're going to add first. So this ends up being our 13y minus 3y. Now I can subtract. 13 minus 3 is 10, and we keep the y. Okay, so I hope you remember doing this at some point. Nothing too crazy, nothing too difficult, I hope. All right, so let's do some where we have to kind of rearrange these a little bit. So let's look at 2x plus 6 plus 3x minus 5. So they're not always going to be like terms that are right next to each other, right? And there might be multiple things going on in a problem. So our goal is to go ahead and put those in order, okay, so that we can perform the operations. So the first thing that I would do is I see a 2x. I'm going to see if there's anything else with an x to the first power. And there is. There is a 3x here. I like to reorganize the problem so that I have my operations right next to each other so I know what to do. So I would do 2x plus 3x. And then if you notice, I have a plus 6 and a minus 5. Well, those are just numbers, so I can order them right next to each other as well. They're just numbers. You can do that, okay? You can go ahead and perform that operation. So what you need to keep in mind is you need to take the signs with them, okay? So if that's adding 3x, you need to make sure you're taking the addition with it. If this is subtracting a 5, you need to make sure you take the subtraction with it, all right? So now I can go ahead and do 2x plus 3x to give me 5x, and then I can do 6 minus 5, so that is plus 1. So 5x plus 1 is our answer for this particular problem. So like I said, you can rearrange them if you choose. You don't have to, but if you're struggling with this, I definitely suggest putting it in order. Okay? All right, let's go ahead and look at 6s, and that's an s, minus 4t plus 2t minus 8. So we're going to look in this problem. Do we have any like terms? Well, I have this minus 4t plus 2t. I don't have anything that I can combine with the s. There's no other s's in this problem. So far, we're going to go ahead and write down 6s. Now I'm going to do negative 4 plus 2. Well, we know that's going to give us a negative 2. And we keep the t, and there's nothing else to combine with that minus 8, so we're going to go ahead and bring that minus 8 down, right? I can't combine anything else. There's no other like terms, so this is our answer here, okay? And that can happen. It can be an easy, simple step. Let's go ahead and look at some more complex problems. So those were some of the easier simplification problems, but let's look at something a little more complex. Let's look at 2c squared d plus 5cd squared minus 7c squared d plus cd squared. Okay, I hate to be the bearer of bad news, but this is going to happen a lot. All right, you're going to see where they have used the same variables and they have given them different kinds of exponents. Okay, so you need to pay close attention. So let's go ahead and look at this 2c squared d. So we're going to look in the rest of the problem and see if we can find a c squared d to the first. Well, I have it right here, this minus 7c squared d. So I would rearrange the problem. You don't have to, but I would do 2c squared d minus, make sure you bring the subtraction with it, 7c squared d. Now I would go ahead and look at this plus 5cd squared and see if I have another c to the first power d squared. And I do, right here. I have a cd squared, bring the addition down with it, plus cd squared. So I can subtract the first two terms, and then I can add together the last two terms, okay? So this term has, or this problem has 1, 2, 3, 4 terms in it. All right, so let's go ahead and look at 2 minus 7, and we know that gives us a negative 5, and it stays c squared d. Now I have a 5 plus, remember if there's nothing here, you assume a 1, so this is 5 plus 1, so that's plus 6, and you keep it cd squared. Okay, so like I said, that's one that's a little bit more complex. I hope it's not too bad for you, okay? Just make sure with problems like this that you take your time and pay close attention to the variables and their exponents. There's a couple more examples in your notes, okay? So let's look at this one. 6x squared y plus 9xy minus 3x squared y squared plus 5xy squared. So let's look at this problem. So go ahead and take a peek. Is there another part of the problem with an x squared y to the first? Nope. Okay, let's move on to the next term, that 9xy, the second term. Is there another x to the first, y to the first? Nope. Let's move on to the third term, which is that negative 3x squared y squared. Is there another x squared y squared in the problem? No, there is not. So let's look at the last term. That's x to the first, y to the second. Is there another x to the first, y to the second in the problem? There is not. So this is your answer, and you could have a problem like that where you cannot combine any like terms. That could happen, okay? All right. Okay, let's go ahead and let's do a problem where you have to distribute and then combine like terms. So let's go ahead and look at 5 minus 2 times the quantity of 4y plus 1. Okay, so we have a little bit of work to do. The first thing we're going to look at, order of operations, is parentheses. Can we do anything inside the parentheses? Nope, so we're going to look out in front. I have a negative 2, so we're going to distribute the negative 2. So if there's a subtraction there, remember subtraction is the same as the negative. You're going to distribute that. So I still have that 5. I'm going to go ahead and bring down that 5. I think my marker's starting to die. So bring down the 5. Now I'm doing negative 2 times 4y. So negative 2 times 4, negative 8, keep the y. Now I have negative 2 times a positive 1. Well, that's now negative 2, okay? Now we can see if we can combine like terms. Well, I have a 5 minus 2. Well, 5 minus 2 is 3. We still have our negative 8y. I can't combine like terms. There's nothing else that's just a number, and there's nothing else with just a y to the first. So this is your final answer here. Okay? All right, let's do one large one. So 7a times 2y minus 3 minus 3 times, it's a bad 5, sorry. Really bad handwriting. 5ay minus 4a. So let's go ahead and do this one. If we can tackle this, we're going to be just fine, all right? And like I said, there's a couple more examples in the notes if you want to refer to those as well. So the first thing we're going to do, order of operations, let's look at the parentheses. Can we do anything inside this first set of parentheses in the first term? No. Let's look at the second term. Is there anything we can do inside the parentheses? No. So now we're going to look to use that distributive property that we learned. So we're going to distribute the 7a to the 2y minus 3. So I have 7 times 2 gives us 14. Now I have an a times a y. So that now becomes a y. Okay? Now I have 7 times a negative 3. Well, that is negative 21, and we keep the a. Okay? Moving on to our second term. We're also going to distribute, this time, a negative 3 to the 5ay negative 4a. So now I have negative 3 times 5 is negative 15, keeping the ay. Now we're doing a negative 3 times a negative 4 is a positive 12, and we're keeping the a. Okay, so now that I went ahead and distributed and used the distributive property, we're going to see if we have like terms. So I have 14 times ay. So do we have another ay in the problem? And we do. We have a minus 15ay. So this is 14ay minus 15ay. Now we're looking at negative 21a. Do we have another single a in the problem? And we do. We have a positive 12a. So make sure you're taking those signs with them. So now I can combine 14ay minus 15ay. Well, 14 minus 15 is negative 1, and we have our ay. Now I can combine our negative 21a plus 12a. So negative 21 plus the 12, is negative 9, and we keep the a. Now you can write your answer this way, or you can write your answer negative ay minus 9a. It means the exact same thing. So remember, you can write the one or you don't have to, okay? So now that we have talked about like terms and simplifying, we even use the distributive property. Now we're going to move on to what's called substitution. Substitution, okay? So basically they're going to give you a value. You're going to plug that value in for a variable and then solve for an answer, okay? So we're going to start with substituting, and it says to evaluate. Let's start simple. Let's do 4x minus 7 when x is 3. So they're telling you the value, the number for x. You have to plug that in. My suggestion for substitution is to put in a set of parentheses for where you need to substitute that value in for the variable. Okay, so x is attached to the 4. Put in a set of parentheses, and that also lets you know that this is multiplication. So we're going to go ahead and put in the 3. Now we're doing order of operations and can simplify. Well, 4 times 3 is 12. Now we're doing 12 minus 7 gives us 5. Okay? Now, let's do another one. And let's say we're evaluating 2a plus 4 when a is negative 5. So I said it's important to have that set of parentheses in place in the problem where the variable would be. And this is because if this is a negative, you need to know that that negative is being included and that you need to multiply 2 times the negative 5 instead of the subtraction, right? Because if you just put it in there, that could turn into 2 minus 5 instead of 2 times negative 5. And this signals multiplication. So now I have 2 times negative 5 is negative 10 plus a positive 4 to end up with an answer of negative 6. So hopefully the substitution isn't too difficult for you, especially because right now you're just dealing with order of operations and solving the problem for a numerical value. Okay. All right, so let's continue on. So like I said, there's several examples. I'm only going to do so many because I'm hoping that you understand this at home. So I'm going to do some of the larger examples. If you need to see another small example, there's a couple of those in your notes. So let's go ahead and evaluate y squared minus 10y plus 25 when y is negative 2. So if you notice in this problem, having that negative in parentheses is important, not only for the multiplication, but when it comes time to dealing with the exponent. Remember, when we dealt with exponents before, we needed to know if that negative was being included with multiplying the exponents or if it wasn't included, okay? So here we see that that negative is going to have to be included because we're sticking those parentheses here. So the negative 2 is being squared. Okay, and the negative 2 is also being multiplied by 10. So now we can perform order of operations. Well, negative 2 squared is negative 2 times negative 2, that's a positive 4, minus 10 times negative 2 plus 25. Make sure you're taking your time and rewriting your problem and that you're bringing down the correct signs. Order of operations, we can now handle the multiplication. So this is 4. Negative 10 times negative 2 is a positive 20 plus 25. Now, since this is all addition, we can add all in one step. 4 plus 20 plus 25 gives us 49 is our final answer there. Okay? So make sure you put these values in parentheses so you know exactly what you need to do for the multiplication and for the exponents, okay? It varies greatly and it definitely changes your answer. For example, let's look at this. Let's look at evaluating 5y squared for y is negative 2. So the first thing I'm going to do, I have my 5, I'm going to put my parentheses and my square sign. Then I'm going to substitute in the negative 2. So if you notice in this problem, according to order of operations, right, there's no parentheses, true parentheses, right? There's no operations going on in here, so we're moving on to exponents. So that negative is included. So negative 2 times negative 2 becomes a positive 4, and now I know I need to do 5 times 4 to get 20. depending on how this problem's done, it can definitely change your answer. So look how similar the problem of 5y in parentheses squared for y equals -2 completely changes your outcome, okay? So I have in parentheses my 5, and I'm going to stick parentheses in for where I need to put that -2. Well, this time, if you notice, I have an operation inside the parentheses. I can do 5 times -2. Well, that gives me -10. Well, now this is -10 squared. So -10 times -10 gives us a positive 100. So it's very important that you take your time, you place those parentheses in appropriately so that you can deal with your signs and end up with the correct answer. Okay? And like I said, you have any questions about this whatsoever, make sure you get a hold of me, okay? I can help you with examples. If you're stuck on a homework problem, message me. I'll help you out with the homework problem and get you to where you need to be for the right answer, okay? All right, so now that we have dealt with that, sometimes they're going to give you substitution problems that have 2 different variables. This can happen. You could have a problem with two different variables, 2 different values. So the thing you need to pay attention to here is making sure that you put in the right value for the right variable. So let's go ahead and start this problem. I have 5a minus 3b minus 2. So 5 times a, so I know there needs to be parentheses here. Well, a is 3, so I'm going to go ahead and substitute that in. Minus 3 times, so I know this is going to be the b. I got to have my parentheses, and I'm going to go ahead and substitute in the 4. Minus 2. So now I can go ahead and simplify. So I can do order of operations. There's no parentheses, no exponents. So now I'm dealing with multiplication or division. We have multiplication. So that's what we're going to go ahead and handle. So I have 5 times 3 that gives me 15. Minus 3 times 4 that gives us 12 minus 2. Now I need to handle the subtraction. So I have 15 minus 12, which gives me 3 minus 2 gives me a whole number 1. Okay, so you're still doing the same kind of operations, the same deal with your order of operations. You just need to make sure you're putting in the right variables or the right numerical values for the correct variables. Okay, so the right numbers for the letters. Okay, all right. Let's do one more of those. We're going to talk about temperature, and that's the end of this section. So let's go ahead and look at x squared minus 4xy minus 4y squared when x is 5 and y is 3. Okay, so let's go ahead and substitute. So I'm starting with an x squared. So we have our parentheses squared, and x is 5, so I can go ahead and substitute a 5 in. Minus 4 times an x. Well, x is 5 times, I need another set of parentheses, y. Well, y is 3, so I can substitute that in. Minus 4 times, I have parentheses, y. Y is 3, I can substitute that in, and that is being squared. Okay, so this one has a couple more steps. So I need to go one step at a time, order of operations. I can't do parentheses, so I'm looking at exponents. Well, I can do an exponent here and an exponent here. So 5 squared, 5 times 5 is 25. Minus our 4 times our 5 times our 3 minus 4 times 3 squared. Well, 3 times 3 is 9. Continuing on with the order of operations, I'm now moving on to multiplication or division. We have multiplication in this problem. So I would multiply right here. 4 times 5 times 3, so I have 25, minus 60. I also have multiplication here, minus 4 times 9 is 36. So now you can take this one step at a time. This is 25 minus 30. You could have also done adding a negative. Remember, we did that rule as well. So 25 plus minus 60 ends up being negative 35 minus 36. I would suggest here adding the negative so you can see that you're doing negative 35 plus negative 36 gives you a negative 71 for your answer. Okay? All right. So like I said, that was one of the longer, more complicated examples. There's several other in the notes, and like I said, if you need help, please ask me. The last thing we're going to cover in this section is dealing with temperature. So temperature is a substitution problem, and there's two different formulas for temperature. So we have, let's see here, which one I want to do first. So for degrees Fahrenheit, you would do 5 times, in parentheses, degrees Fahrenheit minus 32 divided by 9, okay? You may also see this in your book written as degrees Celsius equals 5/9 times degrees Fahrenheit minus 32, and that's fine, but this version is a little easier to manipulate, okay? You're technically not dealing with a fraction, you're dealing with subtraction, multiplication, and division. Here you got to deal with the fraction, okay? So I would do this one first. So let's go ahead and do an example with this. So it says, what is the Celsius temperature when the Fahrenheit, I think that's how you spell it. I'm not very good at spelling, sorry guys. So Fahrenheit temperature is 5 degrees Fahrenheit, okay? So they're asking for the Celsius temperature, they're giving you the Fahrenheit. So you are going to use this formula. So we're gonna start out with 0 degrees Celsius equals 5 times. Now, they want you to substitute in degrees Fahrenheit. Well, we know degrees Fahrenheit is 5 right from the problem. Minus 32, and this is all over 9. Order of operations, we're going to take our time. So now I have 5 minus 32, okay? So we're still our degrees Celsius equals 5 times 5 minus 32 is negative 27. This is over 9. So now I'm handling the numerator. I'm doing 5 times negative 27. This is negative 135 over 9. And if you type that in your calculator, 135 divided by 9, you get negative 15 degrees Celsius. Okay, so that's using and calculating degrees Celsius when they give you the temperature in degrees Fahrenheit. Okay? All right, there is one more. I know it's a long section, guys, I'm sorry. Okay, so now we're dealing with degrees Fahrenheit. So if we want to calculate degrees Fahrenheit, the formula is 1.8 times C plus 32. Okay, so let's look at a problem. They want to know, what is the degrees Fahrenheit temperature when the degrees Celsius temperature is 25 degrees Celsius. So this time we want to calculate degrees Fahrenheit. They're giving us degrees Celsius, so this is the formula that we need to use. So we're going to substitute. I have degrees Fahrenheit equals 1.8 times degrees Celsius. Well, degrees Celsius is 25, so I'm going to substitute in the 25 plus 32. Now we're handling order of operations, so we're going to multiply first. So 1.8 times 25 gives us 45, and from here we're going to do 45 plus 32 for a total of 77 degrees Fahrenheit. Okay, so make sure you kind of study that stuff, study these sections. There's more examples in the notes if you need them. Please don't hesitate to contact me through email at bsmith@belmontcollege.edu, or you can text me through the Remind app, and that was all explained on Canvas, okay? Or send me a message through Canvas. It sends to my email as well, and I will get back in touch with you. All right, thanks, guys.